In my last video, I showed how we can take a Lighting Node Pro and convert it to a standalone RGB controller that can run outside the computer. But then I got to thinking, exactly how many LEDs can I control with a single Lighting Node Pro? Well, what would you think if I told you that I have almost 800 LEDs right here connected to and controlled by a single Lighting Node Pro? Don't believe it? Go ahead and take a look in IQ. You can see we've got two lighting channels here on a Lighting Node Pro. They are configured to do watercolor spectrum. We'll go ahead and turn that channel off. And we'll come in here and we will turn this channel off. And there we go. These are absolutely controlled by IQ, controlled by this Lighting Node Pro, and they are almost 800 LEDs, including the disco dodecahedron, which I don't know where I got this thing from. But with this setup, I could actually control about 1,100 LEDs from a single Lighting Node Pro. And on top of that, it's actually expandable. So you could chain and do over 4,000 LEDs from a single Lighting Node Pro. You want to see how to do it? Stick with me and I'll show you how. Let's start off with a rundown of all of the LEDs that were connected. First, we have 450 LEDs across various WS2812B strips from Amazon. Very inexpensive. You can get them in different lengths, different sizes, different counts of LEDs. We had 450 of them. We had 9 of the original Corsair strips. These have 10 LEDs each. That gives us a total of 90 LEDs. We also had several LS100 strips. We had 3 450 millimeter strips, 27 LEDs each. One 1.4 meter strip with 84 LEDs. And two 250 millimeter strips, each of those with 15 LEDs. And that gives us a total of 195 LEDs. Those LEDs right there come up to 735 total LEDs that were connected. And that does not count the disco dodecahedron. I'm not exactly sure how many are in here. It's certainly more than 50. So that gets us close to 800, maybe even a little bit over 800 total LEDs that were connected to that Lighting Node Pro. Next, how did we provide power for all of those LEDs? Well, in our case, I used an AC to DC adapter. So this is an inexpensive AC to DC adapter you can find on Amazon. It provides up to 120 watts of 24 volt power. Now, if I wanted to provide a lot of wattage of 5 volt power, I could have gone with something like this. This will provide up to 350 volts, 350 watts of 5 volt power. And you can, connect one of these with a little switch, turn it on and turn it off. But I didn't want to go with something quite that big and bulky. So I decided to go with Power Brick, 24 volts. But the next problem is to get that 24 volts down to 5 volts so that it's usable by the LEDs. And so for that, I have a little buck converter in this box. Now this buck converter will convert that 24 volt power to 5 volt for the LEDs. It has a limitation, however, of 75 watts. Last but not least is the SP901E signal amplifier. And what this does is it takes 2 RGB channels as input, it amplifies the signal and duplicates it to 4 output channels. So 2 channels duplicated 4 times gives us a total of 8 channels. Now, when I said we could hypothetically control up to 1,100 LEDs, at least in how it was configured, the way that works is we have IQ configured for a 1.4 meter LS100 strip and 2 450 millimeter LS100 strips. That gives us a total of 138 LEDs on each channel. This is the configuration where I can get the most LEDs out of a Lighting Node Pro. Because even though I can do 192 on one channel by configuring them as 6 QL fans, I can't get to the total of 276 total LEDs that I can get with the 2 channels configured as the LS100 strips. So 138 LEDs configured across 8 channels gives us a total of 1,104 total LEDs. This is where the challenges can come in. 1,104 total LEDs at the power that is typically drawn by a WS2812B LED, which is about 30 milliamps, comes to a total of 165 watts. That is more than this power brick will supply. That is more than this buck converter will be able to do. I couldn't find any specs on the SP901E and how much power it could handle. But if I wanted to actually put all of those LEDs on there, I would have to use one of these. And this, supplying 350 watts, we could easily supply power to 2 or 3 of these SP901Es because they can be daisy chained one to the next, up to 4 of them, I believe. But as I alluded to, the big challenge here is power. Even with what I was doing, even though it wasn't the 1100 LEDs that are the max, it could still come up to 110 watts worth of power, which would be more than I could handle with the DC buck converter. The next challenge that we have to address is supplying power to the individual channels. Now, I use 2 different connectors. I use the Molex SL series. These are what you find on all the legacy Corsair RGB products. They use 3-pin and 4-pin Molex SL. A lot of folks call them proprietary. They're not. You can get these connectors on Amazon. You can get them at DigiKey, Mouser, wherever. They're pretty widely available. The other one that I use is JST SM. A lot of folks just call these JST, which is a problem because JST is a company and they make a ton of connectors. These in particular are JST SM connectors. They are widely used in the LEDs that you'll get off of Amazon. So they're also commonly available. You can get them from Amazon, DigiKey, Mouser, etc. However, both of these are limited to 3 amps per circuit. And when we have 138 LEDs, the standard WS2812 LEDs at full white, we can pull a little over 4 amps worth of power. Now, for short periods, that's probably okay. But for longer periods, we don't want to do that. In fact, for short periods, we probably really don't want to do that, right? So we'll either wind up reducing brightness or just not going with light and making sure whatever pattern that we choose keeps it under the total amount of power that's supported by the connector. So that's something that you really have to watch out for because you can get yourself in trouble with that. A lot of folks like all white, and that's problematic for a number of reasons. Now, what's interesting though is the Aurora strips, and I continue to be amazed by these things. They're incredibly efficient. 138 of the Aurora strips on a single channel will only pull about 2 amps. So they're remarkably efficient. So if you can find LEDs like that are that efficient, that are 5 volt on Amazon or Mouser or wherever, you could absolutely go crazy with those. But the standard WS2812Bs that you get out there, you're going to wind up having issues with power delivery. And on the longer strips, you're going to want to do something where you inject power probably on the other end of it. Now, Corsair had something like this. It was much longer, but it would allow you to inject power on both sides of a long LS100 connection. And with the LS100s that I had connected here with 1.4 meter and 450 millimeter on a single channel, you actually had to use these in order to get full brightness because there is a reduction in voltage for longer runs. So those are other challenges. And the Aurora strips, by the way, they didn't have that problem. They didn't need to use power injection, at least with 138 of them. It made absolutely no difference on the power draw. It made no difference on the brightness. So another thing that's just absolutely amazing about those Aurora strips and makes me really wonder kind of what's going on with those things. So that's how we can control up to 1100 LEDs on a single Lighting Node Pro. But I'm sure you've gathered by now, just because we can doesn't mean that we should. There's a lot of challenges with power delivery and a lot of challenges with making sure that we have enough power available to run all of those LEDs. That said, you can still go crazy with that because let's be honest, what are you going to do with 800 LEDs? I have no clue what I would do with that many LEDs. All right. Now, if you keep it to 90 LEDs per channel, 90 LEDs per channel will give you a total of 720 total LEDs. That's 108 total watts. That's still a bit more than we can do with our buck converter. But it's more reasonable than the 165 watts that we would see from 1100 LEDs. If you keep it to about 500 LEDs, that would take you right to 75 watts. That's still a lot of LEDs to control from a single Lighting Node Pro. And I think that's absolutely doable. If that's not enough for you, you can certainly go up, daisy chain these, use something like this, maybe even use different connectors. But you do need to keep that power budget and power utilization in mind as you put everything together. Thanks for joining me. That's all for now. If you like this video, please go ahead and hit that like button below and subscribe if you want notifications of any new content. I'll be doing more stuff around RGB and mostly Corsair stuff in general, and whatever else happens to strike my fancy at the time. So until then, may your temps be low and your RGBs be bright, and I will catch you later.